X7 R3 expands SD1, the module responsible for the design of steel members, with two new features. First one is connected to the AutoMCR module. In previous iterations of AXISVM, semi-rigidly connected elements to the beam under design got a support stiffness as they were rigidly connected elements. Now these connecting stiffnesses are evaluated more precisely. The implemented correlations are highlighted on this slide. The RH coefficient in the formulas is the hinge stiffness component. Interpretation of this can be seen here. During defining these spring characteristics, beside the initial stiffness, the vibration stiffness can also be given. These stiffnesses can be set when defining the line element. AutoMCR PDF guide covering the theoretical background and application of the function has been updated on our website as well. In the following model, a simple hinged portal frame is presented. The rafters are divided into two segments, one with hinge and one straight. The straight part is going to be investigated. It is getting supported in three different ways. At its beginning, it is a rigid connection. After it comes a semi-rigid one. To present the actual differences, it has semi-rigid connecting stiffnesses in the purlin's connecting end in two components. First is the displacement in the direction of the purlin axis. This means lateral support to the rafter. And the second is rotation around purlin's strong axis. This gives stiffness against twisting to the rafter. These have different manually set characteristics. For the AX component, a 40,000 kN on a meter is set, for example. The last element connects hinged. After moving forward to Steel Design tab, with selecting the examined design member, the design parameters of AutoMCR can be checked. It can be properly seen that by choosing the automatic lateral supports, the semi-rigidly connecting elements support the rafter differently. The second new feature of SD1 is implemented for requests from our partners from the Netherlands and affects only the Dutch Eurocode. For lateral torsional buckling check, the Dutch National Annex provides a special method to calculate C1 and C2 coefficient values. Based on prescribed structural and load patterns in National Annex, AXISVM tries to calculate the factors accordingly. If there are no matching patterns, conservative C values are being used for the LTB calculation. X7 R3 extends the list of recognized patterns with the following two options for the Dutch National Annex for the precise evaluation of values C1 and C2. Distributed force with end moments, concentrated force with end moments.